Welcome to this lecture. My name is Mark Scythian. The date today is September 13th, 2025. So this is solving a common algebra problem where you're given the following question set information: x plus c is equal to 18, where c is equal to y plus 3, where y is equal to d plus 5, and d is equal to x squared minus 10. So the first step is to organize and solve for relevant information. So on the first line, we will solve for c. So c is 18 minus x. And then we can take y plus 3 and make this equal to c, which is also 18 minus x. Then we can solve or substitute y, d plus 5 into y. So we get d plus 5, then plus 3 is equal to 18 minus x. And then we can substitute d as x squared minus 10, then plus 5 plus 3 is equal to 18 minus x. So if we take this expression on the bottom here is the totality of the substituted information, we can solve by adding 5 plus 3 is 8, positive 8 plus negative 10 leaves us with negative 2, then equal to 18 minus x. So if we then solve for this in a quadratic equation form, we have x squared. We bring the negative x over on the other side, so it's positive x. And then we bring the positive negative 2 onto the other side, so it becomes positive 2. So this becomes be made equal to 20, but then we can bring the positive 20 back on the other side and equal the entire quadratic function to 0. So we add 2 on the other side, 20, and we subtract x, or make it as an add function on the other side. So we would actually get x squared plus x is equal to 20, but then we bring the 20 over by subtracting it, so we get negative 20, and then we equal the entire quadratic function to 0. So now we can factor, and the 20, or the c value, the coefficient value, the constant actually, this will break into multiples of 1 times 20, 4 times 5, and 2 times 10. So intuitively, we could see 4 and 5 seem to have something to do with 20 as a product function. So if we add 5, subtract 4, and then factor this out, we can take x times x, x squared, minus 4x plus 5x, and then positive 5 times negative 4 is negative 20. So when we simplify it, we get x squared plus x minus 20. And so that is the correct factorial. So if we would just simply take x plus 5 and make it equal to 0, we know the first x is negative 5, and then x minus 4 is equal to 0. The second x is equal to positive 4. So we can actually substitute and test this into the quadratic function. And when we work it out, we do indeed get the correct answer. We valued the 4 component, the second x, and we too also get the correct answer. So another method, if you're not into factoring, and a lot of these questions are written so they can be factored in whole integer values or multiples, is to just use the quadratic formula. So if you were to just memorize this formula and you're not interested in factoring, you could take the quadratic expression. So the x squared is 1 for a, the x is 1 for b, and then the negative 20 constant is c for negative 20. So if you solve using this method, we would have negative 1 for negative b plus or minus the square root of b squared, so that is 1 squared, minus 4 times a, so 4 times 1, and then times c, negative 20, divided into 2 times a, or 1. So if we simplify the square root function here, we get then 1 squared is 1 minus 4 times 1 times negative 20. So we get minus 1 minus 80, or 1 minus negative 80. So that's a double negative. So these become positive. So this is added together and becomes square root of 81. So again, it is a factorable value. So we get square root of 81 is 9. So we get negative 1 plus or minus 9 over 2. So that would pretty much suffice for the answer. But if you wanted to get the individual x's, you can just work that out. So negative 1 minus 9 over 2 is the first x, and then negative 1 plus 9 over 2 is the second x. So if we work this one out, we get negative 5. And then the same thing again. Negative 1 plus 9 is 8 over 2, so we get 4. So I see this question in a lot of algebra textbooks and several students asking for help, so I thought I would post this as a common algebra problem. So the main takeaway is to organize and substitute where appropriate, and then realize that you're dealing with a quadratic function. So you're able to either factor or use the quadratic formula. Thank you for watching this lecture, and have a great day.